Hey, hi everyone. Very good evening. Hi, Anil. All right, Anil. Understandable. You can just go through with the recordings then. Hi, Jyoti. Good evening. Hi, Harsh. Hi, Govind. Good evening. All right. Fine. So, is my voice is loud and clear to you all? All right. Fine. So, let us get started then. So, before we get into it, so can you post the topics that we have learned yesterday one by one? What are the topics that we have covered in yesterday's session? What are the topics that we have covered in yesterday's session? All right. Random variable and probability distribution binomial, Z-table, stock price analysis, right? So Arti, random variable, Malati, continuous probability distribution, Srisha, discrete random variable, continuous random variable, binomial distribution, gain formula, right? Harsh, okay. Jyoti, stock prices over the years, BEML and Blackstone case study. Wonderful. Binomial distribution, yes, Harsh. So these are the areas that we have touched in yesterday's session. And with that, we completed our statistics topic. So now in today's session, so we are going to get into machine learning. All right. So this is a very important topic, how exactly machine learns a pattern and how it is going to make a prediction automatically. So that's what we are going to study today. All right. So with that, we are going to for that, I will be picking up one machine learning algorithm to just understand how machine learning will work so that you will be getting an understanding about how machine learning. It is very simple, but it depends on one problem statement to the another problem statement, how exactly we are studying, how exactly the problem statement is. Based on the complexity of the problem, the level of complexity also will get increased. But now I'm just going to pick up one simple problem so that we can understand how we are going to work on it with respect to the machine learning problem statement with respect to the complete flow, starting from the business understanding, data collection, data understanding. So that flow we will be till model deployment we are going to cover today. All right. So now let me share my screen, but before that, let me do a quick recap. So we just started from the life cycle of a data scientist, and then Python programming part we completed, and then we touched this Python libraries where we discussed about pandas for data visualization, and then we got into pandas for data analysis, and then data visualization we completed, and then we discussed about statistics. That is, statistics is all about making a statement about present. So now which stocks I have to invest. So to make a decision now, to make a decision present, we are getting into statistics. Now we are going to learn machine learning. Now, the very first question which I'm getting in my mind is nothing but why we have to learn machine learning. Machine learning is nothing but I want to make a statement about future. So machine learning is all about to make a statement about future, or other words we can say in two words, that is early prediction. So to make an early prediction or to make a statement about future, we are getting into machine learning. Now, why we need to go for early prediction is nothing but, let's say there is a mission. I think I've told you the same example already. So whenever we are looking into the manufacturing industry, the missionaries need to work 24 bar 7, right? So if it is working 24 bar 7, we don't know, because they used to get multiple many orders, they used to get it, and it's a continuous orders. So now if the machine, if it is getting failed, so again the stocks will be going for a lot of waiting time. So now if I'm finding a way, if I'm feeding an intelligence with a machine that based on the rotational speed and the load that it is taking in, if I'm giving a machine the intelligence, hey, that is, it was going to give a red alarm, like the way how this car is going to give us. Let's say if you're what is that, AC fuel thing, if it is not, if it is going, if it is getting drained, it is going to give you, raise an alarm, right? Like a red color light stating that, hey, it is going to end, you have to take care of it very soon. Yellow color light. So machine is understanding your pattern. That's what your artificial intelligence is all about, where exactly we are trying to keep a sensor, and sensor is trying to read the patterns, and it is just alarming us. So that is all about machine learning. So to make a statement about future, we are getting into machine learning. Is this point clear to everyone? All right. Now within machine learning, we are having many divisions. Let me share my screen. One minute. All right. Now, if you look into this, hope my screen should be clear. So machine learning is nothing but, I mentioned this, in order to make a statement about future, we are getting into machine learning. So this machine learning is broadly divided into two divisions. One is supervised learning and unsupervised way of learning. So the supervised learning is all about when we are having a specific output, we call it as a supervised learning. When we don't have a specific output, we call it as an unsupervised way of learning. Now, what is a specific output? Unspecific output is nothing but, so in your data set, if you're having the output column, what is that output column? See this. One minute. Let me open my Jupyter notebook. Maybe let me open up. See this. This is one breast cancer data set. All right. So you don't need to look into that completely. But the point is, so you're able to see this data. So just go with pattern reading. So machine is going to learn this pattern, row-wise pattern. It is going to learn. Why row-wise pattern? Now, if I'm just giving you a question that is, hey, can you just give me the number 2, 4, 6, 8? What is the next number? What is the next number? It is nothing but it is 10. So when our human mind is, it is nothing but it is 10. It is nothing but it is 10. Now the point is nothing but here we are human is making a prediction, right? Human is making a prediction. To make a prediction, how we are reading the patterns? We are reading the patterns in this particular way. So in the similar way, when mean radius, if it is 17.99, when mean texture, if it is 10.38, mean perimeter is 122.80, so if machine is going to learn this particular number, and after learning this particular number, after learning the particular number, if I'm having the target, this is nothing but what? If it is 0, that belongs to basically it is a benign cancer and a malignant cancer. There are two types of cancer in the breast cancer data set basically. But the point here is nothing but we are able to have this a target. So your data set is having the output column. So when your data set, if it is having the output column, we call it as supervised learning because we are specific. So if this is the pattern, we can be very specific that this is a benign cancer. If this is the pattern, all right, if this is the pattern, we can be more specific that output itself, it is a given, it is nothing but one. Even whatever we are learning here today, it is with respect to this EDL program, it is also a supervised learning. Why? How it is a supervised learning? Because I am raising the question, what is machine learning? And I'm giving the answer. I'm specific about the answer. Now, if I'm only asking the questions and you don't have the answers, only questions. So there we call it as an unsupervised way of learning. So if it is an unsupervised way of learning, we try to find out some patterns and we try to take it as a supervised learning. Now we are not going to get into unsupervised way of learning in this particular program. Supervised learning will give you an understanding about how this machine learning is going to work. Now, are you clear with the difference between supervised and unsupervised way of learning? I'm just confirming. So Jagadish is saying teaching is supervised, interview is unsupervised learning. Yes, Jagadish, perfect example. Even I can take a screenshot. I can use it somewhere. Thanks for that. Jyoti, that's a good example, I think, what Jagadish has said. In interview, you try to think and you try to find, your human mind will try to take some patterns with whatever you studied and you're going to tell it. Maybe it can be right or it cannot be right. Anyway, if you're trying to find out some patterns related to the questions with whatever you learned. Let me show you maybe another data set for an unspecific output. Maybe let me show this. Your regression. Basically, it will never have this output column. That's it. All right, see this. This is another data where exactly you're having only this data set. Basically, you're having invoice number, stock code, description, product name, quantity, invoice date, unit price, customer ID, country. So basically what we need to find out is nothing but it is an association rule. So which product goes well with which product. So let's say if you're trying to buy some, so here we are having description. So it is another study. So we have to go for a longer study here. But basically what I'm trying to say, we are expecting some result, but that the output won't be available in your data set. So keep that in your mind. Maybe you can do your own research. But the point is, when we are having a specific output target, so that we are not going with the column name, we are not looking for target or to target this particular column name should be target. That's not the point which I'm trying to say. So let's say you are getting a data where exactly it is an eligible or not eligible problem statement. So whether a customer is eligible or not eligible. So in case if your client itself, if they are giving us a data set, and if they are just mentioning one column called as, hey, you're eligible, not eligible, they have to give it. Basically, they have to write it and give it. In case if they're not giving it, and we have to find out some patterns by reading the input data. That's what this unsupervised way of learning is all about. All right, Jyoti, fine. So now see this. I think now you got it. Now let's get into this supervised way of learning. So when we are having a specific output, we call it supervised. When we don't have a specific output, we call it unsupervised. Now within supervised learning, again, we are having two divisions. One is regression and classification. So regression is nothing but when that specific output, that is y, when we are having, we call output, we call it as y. So when that specific output, if it is continuous, what is it continuous? So we can have a lot of examples. That is, here I just listed some examples. See this. When that output, if it is salary prediction, what is output y? It is continuous salary, it is having some units. That output can be like house price prediction or BMI prediction, body mass index prediction. So there are other temperature prediction, commodities prediction. So temperature prediction, it is also having some particular degree, or we can say unit. So I'm not concerned about the input feature x1, x2, x3, x4. I'm not concerned about the input feature. So when that specific output, if it is continuous, we call it as a regression problem statement. So here, if you say in classification problem statement, when that specific output, if it is discrete, it can be 0 or 1. If it is only yes or no, or if it's a binary, if it is binary, we call it as we call it a simple classification problem statement. In case of the output, if it is multi-class, that is 0, 1, 2. For example, based on the input statement, you have to categorize between whether whether it is long or short or medium, what height this person is. That's what a machine need to read the pattern, and it need to make a prediction. And maybe based on this particular input patterns, whether this particular person is coming in under poverty line or a poverty line or a vulnerable category, non-vulnerable category. So basically the output can be of any types. Basically it can be binary classification or multi-class classification. It can be anything. So, but when the output, if it is discrete, we call it as classification problem statement. Few examples are churn prediction, which is very much important. Churn prediction is nothing but there is a bank. So within that particular bank, few customers will be a loyal customers, few customers, they won't give any much profit. Now I have to make a prediction when customers are going to leave the bank, early prediction. So because if I'm going for early prediction, I can reach them out, I can just give some offers, I can keep them in. So because if I'm losing my customers more, I'm at the end of the day, I'm not going to get more money. So that's what the point here. Loan approval prediction, whether the person is eligible for loan or not. Rainfall prediction based on some input features, some, let's say, a temperature, humidity, or overcast. So in this way, based on some certain features, if you're going to predict yes or no kind of statements, we call it a classification. Now, within this, that's what the point here I just mentioned. So we are discussing about supervised learning. When we are having a specific output y, we call this a supervised learning. And when that output y, if it is continuous, we call this a regression problem statement. When that output y, if it is discrete, we call this a classification problem statement. Now, based on the next 2 point is here. So based on, we are having two models. One is parametric models and the other one is non-parametric models. Based on whether it is a parametric model or a non-parametric model, my algorithms is getting classified. Now, what is a parametric model? Parametric model is nothing but parametric models comes up with, maybe we can say parametric. Parametric is nothing but this algorithms comes up with a lot of assumptions. Models is nothing but a collection of algorithms. So within parametric models, we are having some algorithms like linear regression, logistic regression. Within non-parametric models again, it's a collection of algorithms. Non-parametric models is nothing but you can take it in this way. There is no assumption at all. So within this non-parametric models, we are having some algorithms like decision trees, random forest, support vector machines, k nearest neighbors, gradient boosting algorithms, extreme gradient boosting algorithms. In this way, we are having lots of non-parametric models here. Now, what we are going to discuss in this session is nothing but parametric models. Within parametric models, we are going to get into this particular regression problem statement, where exactly, if you see, y is continuous, we call it a linear regression. We are going to discuss about parametric models, not non-parametric models. We are not going to get into it. Within parametric models, specifically, we are going to work on a regression problem statement, where exactly this regression is again having linear regression. Classification, it is getting classified into logistic regression. Now, again, within linear regression, we are having two divisions. One is simple linear regression and the other one is multiple linear regression. Simple linear regression takes this equation y is equal to mx plus c. Multiple linear regression takes multiple inputs. Based on that, it is going to make it. Where m is nothing but slope and c is nothing but intercept. So just note down these points. We are going to go for another blackboard. but just take everything. Now, parametric models major deliverables is nothing but coefficients and intercept. Now, note down all these particular terms. We are going to get into it. All right. Let me give you 1 or 2 minutes time. You will be just note it down, and then we will be getting into the other blackboard where we will be understanding each and everything in detail. All right. So 2 minutes time. Just note it down. All right. Hope it should be done. So again, let me repeat it. Machine learning. There are two divisions, supervised and unsupervised. When we are having a specific output, supervised. When we don't have a specific output, unsupervised. Within supervised, we are having regression and classification, only two different definitions. And based on parametric and non-parametric models, my algorithm is getting classified. Parametric models comes up with assumptions. Non-parametric models, no assumptions. Now we are going to discuss about parametric models. That is only regression problem we are going to work on. So when y is continuous, we call it regression. And linear regression is divided into two types. One is simple linear regression, multiple linear regression. When simple linear regression takes its mathematical equation, multiple linear regression takes its mathematical equation. Up to this clear, everyone? It's confirming. Up to this clear? Jyoti, yes. Jagadish, Srisha. Rishikesh, fine. All right. So wonderful then. Now let us go to another screen. Let me see this. So we are going to discuss about linear regression. We are going to discuss about linear regression. All right. So see this, let's say the client had given this data set to us. All right. So it is going to be a salary prediction. All right. Example, problem statement, what we're going to pick up. It's nothing but salary prediction. All right. Salary prediction. Now you're having some data set like this. That is based on experience. You're going to predict the salary. All right. Let's take it in this way. When experience is, if it is 1, the salary is 10K. Experience, if it is I'm just denoting a simple data set. Experience is 3, salary is 30K. Experience is 4, salary is 40K. Experience is 5, salary is 50K. All right. Now when experience is 6, salary is 60K. Now this is your client given data set. Imagine you're having it is a client given data set. So how many inputs you have here? How many inputs you have here? How many inputs? This is only one input. Is it 6 inputs? Okay, you're thinking about it. Basically, I'm speaking about feature. How many, okay, so how many input features we have? Maybe I should have fine-tuned it. X, Y. It is not two, only one input feature and one output feature. All right. So based on my experience, it is not X, we can say. Based on my experience, I have to make a prediction for salary. So this is the client given data set. Now the client, now we got to understand this. Now I'm having a question. Now you're able to see this particular pattern when experience is 1. Now let me ask this question. When experience is 9, what is the salary? When experience is 9, what is the salary? 90K. So how you are making a prediction? 90K. How your mind is making a prediction? How your mind is making a prediction? Okay, Chaitanya. Experience multiplied by 10K. Increment by 10K. So it is nothing but, see this here, we are able to see one pattern, right? So pattern is nothing but for 1 unit increase in experience, there is 10,000 unit increase in salary. So here for every, that's what the pattern. So the same thing, what you do maybe in your schoolings and everything depends on the previous data. So whenever we are going to make a prediction, the past data, this historical data is very much important. All right, this data, whatever we are having in our hand, it is pretty much important. So if this data, if it is not clear, then it is going to impact your prediction. Now, if this is your data set, maybe in your schoolings and everything, what you do is nothing but to make a prediction. We take this data, and we represent this particular data in this line. Where exactly you take this line and you draw like this. In your graph sheet, you try to draw it, right? So let me take x-axis nothing but experience, and y-axis nothing but salary, experience and salary. So experience, let me take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. In this way, it tries to go. Now here, let me take 10K, 20K, 30K, 40K, 50K, 60K, 70K, 80K, and in this way it goes up. Now what I'm trying, now I'm just looking into the first observation. The first observation is nothing but what? The first observation is this one. So when experience is 1, salary is 10K. Okay, let me keep a point. When experience is 2, salary is 20K. Okay, let me keep a point here. When experience is 3, it is 30K. It is 4, it is 40K. When it is 5, 5 here, when it is 5, it is 50K. When it is 6, it is 60K. Right? Now this is the data what you have. Now what is the point now? When experience is 9, this is where we have to make a prediction. Now what we try to do in our schoolings is nothing but to make a prediction. We try to take a scale like this. Okay, I think we don't have this. What we do is nothing but we try to take a scale, maybe something like this, and we try to draw a straight line connecting all these points, right? Even if some points, if it is not highlighted, we try to keep a bigger dot and we try to round this. Something we do there, but I'm not getting more into it. But the point is we are trying to make all the points connected within this particular straight line. Now, when we are extending this particular line, all right, now when you're finding out this line, we try to keep it. And where this at this particular point, where exactly this y point into, we look into it. So here it is not a perfect figure, but actually it will come to 90,000. So this line, we call it as equation of a straight line, or we call it a regression line. where this regression line is having a mathematical equation. This line is having a mathematical, to construct this line, we call it as a regression line. Y is equal to mx plus c, where m is nothing but slope. The slope determines the direction, whether I have to connect the points in this way, sorry, whether I have to connect the points in this direction or in this direction, in this direction. It is going to look at the directions of connecting between 2 points. Now C is nothing but intercept. Intercept is nothing but the point at which this x is 0. So here if you see C is equal to, it should be 0 basically. But the point is, the point at which this particular regression line crosses this line y, where x pointing to 0. That's what this intercept is all about. Let me repeat it, you can note it down. So the point at which this regression line crosses the y line at which x is equal to 0, we call it as an intercept. So to calculate the slopes and intercept, we are having a mathematical equation. So maybe you can just rely on it. So rely on internet to get it. Right, Jyoti. So you can rely on internet to get it. See this. I think a slope should be equal to x minus x bar divided by y minus y bar. Something, this kind of equation it will be coming in. But you can just, based on C is equal to, let me just look onto it. Even we are having one material, let me just open that. Even we can take it from internet also, but here it will be very quick. All right, so this is nothing but equation of when we are having multiple inputs, we can get rid of. See this? This is when we are having multiple inputs, we will be getting into this particular equation. Change in x divided by change in y divided by change in x. Great, Chaitanya. So that is nothing but y minus y bar. That's what the equation. So here the equation, it will be y minus y bar divided by x minus x bar, where x bar and y bar is nothing but your mean. So how to calculate the mean? A normal mean is nothing but it's basically summation. What is this y? So 10k minus the total summation. If you take it, it will be coming around 30k, I think so. So 10k minus 30k plus 20 minus 30k plus 30 minus 30k plus 40 minus 30k plus 50 minus 30k plus 60 minus 30k. So totally, if you do it, you will be getting one part, and divided by 6 if you do, you will be getting the slope. Now take that particular slope and insert it here. So and the value of x you can just give it. X is nothing but 9, and c also you can give it. C is nothing but here the equation is y bar minus mx bar. So is equal to y bar minus x bar. So now once you get this particular slope value, y bar is nothing but your output y. Output y is you can just take out this particular mean minus slope value, you're getting it. X bar is nothing but the mean of this particular input feature. So if you do it, you'll be getting the intercept. So now if we substitute here, we can make a y prediction. So this is all about your particular machine way of learning. So without having the slopes and intercept, it is not going to be very easy for us to go for the prediction. So that's what is the deliverable of parametric models? What is the deliverables of parametric models? What is the deliverables of parametric models? Nobody noted down the points what I've shown the other screen. I've given 2 minutes time for that. What is the deliverables of parametric models? Oops. No answer. Okay, now Aditi comes up here. Coefficient and intercept. Wonderful, Aditi. Good observation. Kyle, yes, we are going to make a prediction, Kyle, but the major deliverables, if I'm speaking about it, it is nothing but coefficient and intercept. Now let me ask the same question in the other way. Now we looked onto this particular study. Now let me ask you some questions. So during the training time, observation, let me just give some pointers, observations. Now you're going to answer me well. Let me see. Now I'm just going to divide it into two phases. All right, observations here. Let me take this. Now during the training time, during this particular training time, where the client has given the data, what are all during the training time, what are all your known features and unknown features, known parameters and unknown parameters. So during a training time, just imagine, training time is nothing but only with respect to mathematical equation, the algorithm, my machine can learn the pattern, which with what equation we are using it? Y is equal to mx plus c, right? Y is equal to mx plus c. By using this particular equation, we are making my machine to learn the pattern. Even that's how human is learning. So in the training time, what are all the parameters you know is nothing but the client given data, only x and y, right? So the known parameters are x and y. Only you know x and y, you don't know anything. So what are all the unknown parameters? You don't know m and c. So you don't know the slopes and you don't know this particular intercept. Now, from this particular training time, you got the slopes and intercept. The next equation, during the test time or the prediction time, the same question. Again, I need to use this particular, maybe we can say y prediction is equal to mx plus c. mx plus c. Now, in the test time, what are all the known parameters? What are all the known parameters and unknown parameters? Can you just give me the answer for this? During this particular test time, what are the known parameters? Only M and C? Wonderful. So we know because we are going to pass this particular grid checklist. So Harsh, is it also Y? How do we know why? I just raised this question to you. During the prediction time, I asked this question. So I just want to make a prediction when experience is nothing but 9. So you made a prediction. So at the time, you know your X, that is nothing but the input. From the training time, you got the slopes and intercept. So now you know M, X, and C. Unknown parameters, nothing but Y prediction. Now you wanted to make a prediction. Got my point, everyone? All right. Now see this. Now here we made a prediction. Okay. Now if my Y prediction, if it need to be better or if it need to be good, my X and Y, or we can say we need to have best slopes and intercept value. All right, because the data set, whatever I've shown you, it is very easy. Experience is 1, salary is 10,000, 2, 20,000. So I will be getting definitely best MNC value. It won't be that much tricky. So the point is nothing but if my prediction need to be better or the best, my slopes and intercept need to be best. If my slopes and intercept need to be best, my actual data, that is nothing but X and Y, it need to be better. So how can I say my actual data need to be better? So this need to follow some sort of assumptions. If it is following some sort of assumptions, I can say that my data is the best data. So if my X and Y, that's what the parametric model is all about. So if my all my assumptions are matching, then I can say I've got the best data. If I'm getting the best data, my slopes and intercept, it will be best. If my slopes and intercept, if it is best, then the Y prediction, it will be best. Got my point, everyone? Ram, sorry, I can't speak Hindi, Ram. Only one language, in English. All right. So that's what this particular point. Now, what are all these particular assumptions? I'm getting a question. What are all these particular assumptions? All right. What are all these particular assumptions? I'm getting a question. So that's what we will be seeing in the next screen. So up to this clear, everyone? Let me repeat it. See this, we are learning about this linear regression, where exactly linear regression is having this particular mathematical equation. So y is equal to mx plus c. So this is a simple linear regression. Now, in case if you're going for a prediction like experience, and in case if you're having one more column like here, like skills. So in this particular skills, if it's a BE, electronics and communication diploma, in this way, if the number of input features if it is increased, then how exactly my y will come here? Y will be equal to m1 x1, because here m1 x1 plus m2, I'm having the second column, m2 x2 plus c. So number of base, if you're having more input features, for all your input features, you're going to have the slopes. And that's what we call it as multiple linear regression, when we are having multiple, more than one input feature. So here only one input feature we are having it. So we call it a simple linear regression. And now what we have done with respect to this data, we are constructing a linear line. So this linear line is having a mathematical equation y is equal to mx plus c, where m is slope and c is intercept. Now we got to understand with respect to the training time, we are using this x and y to find out slopes and intercept. After finding out slopes and intercept, we try to make use of this equation, and we try to go for the prediction. That's it. And the major point is nothing but, if my prediction need to be better, I need to have the best slopes and intercept value. And how can I say I'm having best slopes and intercept value? The actual data x and y, it need to be the best. So how can I say actual data x and y need to be best? It need to follow some sort of assumptions. Up to this clear, everyone? All right. Now let me show you what are all the assumptions that we have to follow. All right. See this. So see, that's the same point. So linear regression algorithm is nothing but it's coming under parametric model. Parametric model do come up with a lot of assumptions. One point to remember, unless and until we match all these assumptions, the linear regression algorithm won't give the best predictions in the production line. So we have to make sure all these assumptions are matched. All right. Now, what are all the assumptions? The first assumption, that's the same point. If my y prediction need to be better, I need to have best slopes and intercept. Slopes and intercept completely depend on the actual data. So the actual data need to follow some sort of assumptions. I just listed the some assumptions here. The first assumption is nothing but the data need to be linear in nature. What is this linear in nature? When x is directly proportional to y, or x can be indirectly proportional to y. So now what is this linearity? Maybe directly proportional, indirectly proportional. One, if x increases, y should increase, or if x increases, y should decrease. Now what is the point? Maybe you can think of this particular point. That is, here you can take the same example, that is experience, salary. Now the point is like this. Now when experience increases, salary increases. So x directly proportional to y. You can think of some other example like this. So here when alcohol consumption increases, let's say lifespan or maybe usage of car increases, the mileage drops down. Okay. So now basically this is what the same point is. Ram, a little bit slow English would be great for students to understand. Okay, sorry for that. Okay, I'll speak a bit slow, Ram. Sorry, I don't know Hindi. I can't speak that. That's the reason I said. Veera, then only we will get slope line. Yes, Veera, right. So the point is nothing but I need to have this line like a linear one. So it can be increasing or it can be decreasing. So that's what this particular point is. So if X increases, if Y decreases, we call it as X indirectly proportional to Y. So basically I need to have this kind of linear line when I'm taking two features. So how can I check the linearity between two input features or between two features? Any idea? How can I check the linearity between two features? We have already studied about it. Slope. No answer. Okay. So to understand the relationship between two features, we look into what? Rishikesh? Nope, that's not the right answer. To understand the relationship between two features, we look into, I think Srisha got the point. To understand the relationship between two features, all right, I think everybody is forgetting the old topics. We look into scatter plot. So when X increases, Y is increasing or not, or so that's what we look into scatter plot. So the way to check this first assumptions, we will be looking into scatter plot. So scatter plot is used to check the linear association between two features, whether it is positively correlated or negatively correlated. What is this correlated means? Correlated means increasing, or what is the relationship? And the other one is nothing but we are having something called as correlation matrix. This correlation matrix is used to right, Chaitanya. So this correlation matrix is used to understand the strength of linear association between two features. How strongly the features are correlated. Now, what is the strength of relationship? Now here I'm having, let's say, Srisha is there and Chaitanya is there. Now Srisha and Chaitanya both are friends. Now Srisha is having lot of friends with her. Now Srisha and Chaitanya both are very close friends. Now we are saying close friends. Now the strength is little bit varying compared to all the other friends. In a similar way, when we are having multiple features, how the strength is between two features, to understand that we are getting into correlation matrix. All right, just note it down. And homoscedasticity, maybe you won't be getting it now, read about it. So basically, there should be similar variance across the data points. Maybe if you're getting into the program, I will be explaining all about it. But for today's section, homoscedasticity check is not required. And no multicollinearity. Again, no multicollinearity is nothing but there shouldn't be dependency between independent features. That is, when you're having more input features, so one input feature should not be dependent on the other input feature, basically. Now, what is that meaning? Meaning is nothing but, see this, you're having height and weight. Based on height and weight, what we can predict is nothing but we can predict BMI. Now, if height is not, now how many input features I have? X1, X2, Y. So we need to have only one output feature. That is very mandatory here. Only one output feature, we need to have it. Now, X1 and X2, we are having two input feature. Now let's say height in centimeter, height in weight in kg. Now, in case if you're having some column like weight in pounds, this is also, we can say X3. Sorry, X1, X2, X3. Now, here I'm having some value. All right. So here, this value is completely linked up with this value. Now, if you change this particular value, this value weight in kg also will get changed. So which means that there is a dependency between these two columns, weight in kg and weight in pounds. So this kind of dependency between input features, very important point. So this kind of dependency between input features, it shouldn't be there. There should be only one dependent feature, that is output feature. Based on all the input features, I need to have only one dependent variable in my data. So that is the parametric models assumptions. So in case if you're going for non-parametric models, we don't need to check for this multicollinearity. So the point here is nothing but there shouldn't be any multicollinearity between my input features. Is this point understandable? Multicollinearity. All right. Now the next assumption is nothing but the no auto regression. No auto regression is nothing but what the output y should not be influenced by time. That is nothing but basically your input features should not be a time based. Time based is nothing but date time column. So none of your input features should have date time column, and zero residual mean across the filter line. So this also we will be learning it with respect to scripting. So now these are all the assumptions. Now if all these assumptions are matching, only then we can make use of this linear regression algorithm. So if any of these assumptions, if it is not matching, then we can't use of linear regression algorithm. Then what need to be done? So here what need to be done is nothing but, so here we have to look on to this particular next algorithm we can do, or some fine tuning we can do with respect to the same thing. With the rest, by using the same algorithm, we can do some model optimization techniques. A lot of things can be done. But here, let us just stick with this base. The base is nothing but unless and until all these assumptions are matching, my algorithm will not do a better prediction. That is my algorithm will never give best slope and intercept value. If I'm not getting best slopes and an intercept value, then the y prediction, it will get impacted. Obviously, at the end of the day, prediction is going to get impacted. So that's what this particular point. Clear everyone up to this? Able to understand? All right. Now let me show you one business problem. Just take a read on it. All right. And then now we will be going for 5 minutes break, and you can take a read on it. And what you're understanding from this particular data, you can speak to me. All right. Maybe I will be giving the time as 7:57. What is the input feature? What is the output feature? What we have wanted to predict it? Why we wanted to predict it? What? Why? All right. I'm focusing on two questions: what and why. Maybe you can take 7 minutes time if you want, but understand this business problem. And after this, we are going to work on the scripting part. All right. So your 7 minutes, is that fine for everyone? We can go for 2 minutes break, come back, take a read on this, only 2 to 3 lines problem statements. So I'm just giving you more time. Let me start the timer. All right, so here the timer will be visible. Now I'm sharing this particular thing. Just take a read on it. Zooming in. Just take a read on what is the input feature, why, what, and why. So that's what is the input feature, what is the output feature, and why we have to go for this particular prediction. 7 minutes time starts now. If you found it, you can just give me your answer on the chat box. I've already increased it, Dr. Vida. I think it should be visible. All right. All right, is everyone back from break? Jagdish, okay. So Harsh has given me his idea. It's partially right, Harsh. What you have given, it's partially right. Appreciate it. All right, nobody has given it. It's okay. Just see this. Now here, let me take a read on it. So business case. So before getting into scripting and everything, the very first point is nothing but understanding this business problem, what we have to do here, why we have to make a prediction, how we are going to help this particular business, and in that way we have to think it. So thinking is something very important. And before we go for directive prediction, directly we should not jump into the prediction and work on it. That should not be the mindset. uh, our mindset should be like a business perspective, how we are going to benefit the organization by solving this particular problem, very much important. All right, so okay, Jyoti. Mm, X is discrete, and Y will be difference between Sunday and weekday circulations. Okay, Jagdish, all right. So Dr. Veera saying 33 newspapers Sunday circulation is more than barely out of 34. All right, Dr. Veera. So the point is nothing but since we have learned about this machine learning, how it is making your predictions and everything. So here you're having one input feature, that is, in order to investigate the feasibility of starting Sunday edition. All right. Now the business wanted to already is doing some daily feasibilities or daily circulations newspaper is going for. Now this business is going to start a Sunday edition. But before investing it, so they wanted to go, they what they did for large metropolitan newspaper, information was obtained, that is data has been collected from a sample of 34 newspapers concerning their daily and Sunday circulations in thousands. The point is nothing but we have collected 34 different newspaper names, or maybe in India we used to have Hindu and different newspapers we have it. Right? Maybe in other countries also, when foreign countries, they have multiple newspaper names, Baltimore Sun and the Boston Globe, Boston Herald. There are different newspaper names there. So now, if they are going for daily circulations is happening for 391,000. Let's take it as 391,000 and 516,000, 355,000. So in this way, the daily circulation is happening for this kind of benefit. And based on that, so daily they are taking it, and if it is on particularly on Sunday, because it's a weekend and everything, they will be going for more. So, but with respect to Baltimore Sun, it is Sunday circulation is going for 488. But there are some cases, both Boston Herald 355, but Sunday it is just going down. So mostly in all the cases, when daily is increasing, sorry, daily if it is 270, the Sunday circulation is basically increasing. Now, my input feature is nothing but daily. My output feature is nothing but Sunday. Based on the newspaper name, I can't go for Sunday prediction. Here, the output is a discrete or continuous. Output is a discrete or continuous. Is it continuous, Veera? Sunday circulations in thousands it is. It is continuous. It's not discrete, it is continuous. You can think it is something like a return. What the return it is just giving it to me. $1,000, you can just think of it. $488 or $488.5. In that way, you can think about it. All right. Fine. So it is continuous. Now, based on the daily circulations, I have to predict the Sunday circulation. Now, why we have to make a Sunday predictions? How we are going to benefit the business by solving this system thing? But now I want to figure, because we know when daily is increasing, Sunday is increasing. But if the daily feasibility, if it is somewhere around for $400, I'm getting it. I want to know the figure, whether I will be getting 600 or 700. When X increases, Y increases. Everybody knows it. But what is that figure? I wanted to check it out based on this data. Not like just assuming it. Based on this particular data, I need to go for the prediction. Now let me just show you one script. Just take a look at it. I think you should be able to get it. Mm, So what I'm doing, I'm just importing this particular pandas as PD. All right. And just look onto this. I'm importing pandas as PD here. And then with respect to pandas.read underscore CSV, I'm having this particular newspaper data as a CSV file. I think this file CSV file is attached in your dashboard also. I'm reading this particular file and I'm just looking onto it, how exactly it is and everything. I'm just looking into it. Now I'm having totally 34 different newspapers because it's starting from zero basically. So I'm having 34 different newspapers and the daily circulations and Sunday circulations I have it. Now business understanding is done, data collection is done. Third step is data understanding. Now I'm just looking into the initial analysis. So totally there are 34 different newspapers and across three features. And is there any null values? I'm checking it. There is no null values. And what is the data types? A newspaper, it is an object. Daily, it is in float and float. Anyway, I don't want this newspaper names because let's say, let me ask you this question. Let's say here I'm having Dr. Veera. Now let's say if Dr. Veera is going to test whether she's having COVID or not, based on the name, am I going to classify between, hey, Dr. Veera, she should not be having COVID? Based on the name, am I going for any prediction or based on some readings, temperature reading, pressure level? What do you say? Based on the names, can I go for a prediction? Newspaper name and everything? No. So I don't look into this particular newspaper name. I want based on the daily circulations, what would be the Sundays. That's what I will be looking into it. Right. Now, we understood it. Initial analysis done. Now, again, what we want to do is nothing, but we wanted to perform this assumptions checks, right, Jyoti? So we want to perform the assumptions check. The first assumption is nothing but linearity check. When X increases, Y is increasing or not. So now what I'm doing, I think we use this particular scatter plot by using Seaborn scatter plot, SNS. This particular SNS I've already imported in line number 1. This is import Seaborn as SNS. I've already done it. Now what I'm doing, so SNS.scatter plot, X is equal to daily and Y is equal to Sunday. And I'm just looking onto it. So is it this particular scatter plot is X is directly proportional to Y? Is this X is proportional to Y? Yes or no? Is X daily circulation is proportional to Sunday? Yes, it is proportional. But the point is, if I'm drawing, in case if I'm drawing a straight line, if all the points, this blue color points, if all the points falling onto this particular line, then it will be more better, right? For prediction. What do you say? If all the points falling onto this line, then it will be the prediction also, it will be better. Yes or no? But some points are scattered. So in that way, my prediction will be, it's going to make a prediction, but accordingly based on the scatterness, because that's the nature of the data, we can't do anything. Based on this, my prediction also will be it will be doing some errors. But if you are expecting all the points linearly, we don't need a mission. Yes or no? In the previous case, what we have studied, experience versus salary, do we need to hire a data scientist and paying him 60,000 per month and say, if experience, if it is 9, what is the salary? If there is no randomness, do we need to hire any person for that? No. So we can't expect that kind of linear, very easy data in the production line. So the data set will be something like this kind of complexity. So now with respect to this randomness in the data, how we are going to make a machine learn this pattern and making a prediction and how we are going to reduce the error, that's what this particular point is all about, right? Now I think you got this point. Now, since you're having only one input feature, the daily versus Sunday, we checked it. Now, instead of this particular scatter plot, in case if you wanted to draw a linear line, that linear line should make sure it need to connect most of the points. So within Seaborn, we are having something called as linear model plot. So with respect to it, just it is going to construct a linear line. That's it, the same thing, but this line is going to take most of the points falling onto it. This is the best line basically, but it is very evident that most of the points are not at all falling it, but very close to it. Right. Linearity test is done. Now the second test is nothing but normality test. I have not listed it there, but normality test is nothing but your input feature should be normally distributed. So what is it normally distributed? When I'm taking, what is the input feature here? Daily. When I'm taking the daily, how to check normality? Any idea? How to check whether my data is it normally distributed or not? What are all the plots that we have discussed? How to check whether the data is normally distributed or not? Is it scatter plot or the scatter plot? It's a bivariate analysis, right? Great, Rishikesh. Wonderful. Amol, what does it mean? Zeros to variance one. The plot. I'm asking about the plot. Yes, Harsh, right. We can look into histogram or we can look into dist plot, which is going to give me the figure. So instead of using histogram, I'm using this distribution plot where exactly I'm taking only one variable daily and histogram is equal to false. I'm making it, or else what will happen is nothing but I will be have where exactly I'm getting, just try to give shift triple tap. You will be getting all this particular arguments and everything. All right. When you're practicing it, just go step by step. Don't go shift enter, but try to take line by line and try to understand it. All right. So now, is it normally distributed? Let me check the skewness. Can we say it is normally distributed? 1.5 it is 1.53 basically. Is it normally distributed or what? What do you say? Is the skewness can be accepted? Is it in the acceptance range? No, it is not in the acceptance range. Because if you see, most of the data are tended towards right. So there we can say there is little bit of skewness towards the right hand side. So that's what the point. Even the skewness is nothing but we say 0.5 to 1. That's what the maximum. But beyond 1, it is it is bit dangerous. That's what the point. Right. Now, multicollinearity check. It can be performed using something called as correlation matrix and variance inflation factor. You can check it out. But with respect to simple linear regression, already we are having only one input feature. In case if you're having more input feature, we could have checked this multicollinearity. Now we don't have it. Auto regression. There is no time-based input feature, time-based input. So all you're having only daily as an input feature. You don't have it, so we can't check for this auto regression. And homoscedasticity check and zero residual mean check. This can be done only post model training. So in the next session, maybe not tomorrow, maybe if it is a 3 months program, I would be taking that part, these two tests in the second day of linear regression, but not today. You can just read about it. So now with respect to this data, we check for linearity, we check for normality. So linearity is also not at all pretty good. Normality is also not failing. So two tests are failing. So now what do we do? What do I do is nothing but third step, data preparation is data understanding is done, and we found that assumptions are not matching accurately, but it's bit okay. Now the fourth step is data preparation. In data preparation, what we try to do, we try to delete this particular newspaper column because that column is not at all required. So we delete it and we are having daily and Sunday. These are the two columns, and we are making sure there is no null entries. Now what we can do is nothing but, so linear regression algorithm, if you take, linear regression can be built by using two libraries. So anyone you can pick it up. So using one library called the stats models library, and there is another library called as sklearn library. By using these two models, you can build it. Now I'm going to focus on this particular stats models. Now, if stats models, model building and training will happen at the same time using one technique called as ordinary least square technique. Now see this, I'm going to import stats models. So just give a dot already, just give a dot and tab button. Let me give a dot and tab button. If you give, you will be getting this formula or formula, and then dot. If you give it, you will be getting the right package. Now by using stats models dot formula dot API, I'm just going to give a nickname like SMF, which means stats models formula. All right. Now I'm importing it. So within this again, SMF dot, within this particular thing, there is something called as ordinary least square. Within that, we are having this formula and data you're having it. Formula is nothing but it should be in a string. So for that reason, within a string, how we have to give the input and output is nothing but, in model building, what we do, we try to segregate between input and output. So here what we are trying to do is nothing but in model building. So we are using this tilde symbol. So before the tilde symbol, you're going to take your output. All right, you're going to, Sunday is nothing but my output. After tilde symbol, you're going to take your input. That is nothing but daily. In case if it is more than one input, we try to give plus, and we try to go for x2 plus x3. In this way, we try to go for. But here we are having only one input, so daily we are giving it, and the data is nothing but newspaper data. And then we are saying dot fit. Dot fit is used to fit this particular x and y to this particular thing. Now see this. This particular intelligence got fitted over here. Now, if you see what is the deliverables of this particular model training. Now model training is done. We trained our particular data. with the given data. Now, what is the deliverables? If you see this linear model, now whatever the intelligence I got it, I just stored it in linear model. Now, even if you see this linear model, it will be a kind of object. You won't be able to see it, but it has been a wrapper. Whatever the intelligence we have wrapped it. Now, this linear model is having the intelligence. Now, if you say the linear model dot, if you give tab button, you'll be seeing A, C, B, C, a lot of things you should be able to see. Now, what I'm looking onto, it's nothing but there is something called as params. All right, params. Params is nothing but parameters. So the deliverables of model training is nothing but slopes and intercept. Now, if you see intercept, intercept is 13.83, that is C. Slope is nothing but 1.33. Now, model training is 10. So let me repeat the cycle: business understanding, data collection, data understanding, data preparation, model building, model training, more post-model training, model testing. So now within model testing, I'm just going to divide it in two divisions. One is manual calculations. What is the manual calculation? So y is equal to mx plus c. That is the equation what we have. Now what I wanted, if x is equal to 200, what do I mean by x is equal to 200? So if daily circulation, if it is going for 200,000 sales, what would be the Sunday circulations? So now what I'm doing, what is the equation? M is nothing but so that is slow 1.33975. So 1.33975 multiplied by x is nothing but what? 200 plus 13.83. This is nothing but the intercept. So now I got it 281.77. That is nothing but what? Your Sunday calculation. So if your daily circulation, if it is 200, your Sunday circulation, if it is $281. Now, if it is 300, so the slopes and intercept is not going to get changed. Slope is nothing 1.339 multiplied by x. Intercept is this 415. This is something manually you can do it. But how machine is going to do? Machine within this particular linear model, if you give dot, there is something called as predict as a function. So within this particular predict, we have to pass only the questions. Only the x we have to pass it because already this linear model is holding the slopes and intercept. Now what I'm doing? Now I'm just prepared one data called linear demo because we don't have any test data. This linear demo is nothing but I'm just prepared it. So now if you see daily circulation, if it is 200, Sunday circulation, if it is 300, sorry, daily circulation, if it is 300, and if it is daily circulation 400, only the questions you have. Now what I'm doing, linear model dot predict, you're passing this particular test data. Now see this, it is making a prediction. 281.77, 417, see this? It is making a prediction. Now this is the same thing, right? Manually 281.77, machine is also doing it. 415.75, 415.75. Now what we do, where is intelligence throughout the whole script? Where is intelligence available? The intelligence is available in linear model because here you see, this is where we have transferred that intelligence to linear model. Now we take that linear model. Now it is a Python file. So machine is not going to understand the Python file. Machine is going to understand your binary format, whether it is zeros or one, or it is going to understand the data in another format. So what we do, we have to convert this intelligence of this linear model, which is a Python programming part, into a machine understandable language. So to have it as a machine understandable language, we are having one library called as pickle. So from pickle, I'm going to import something called as dump. All right, just go step by step and try to do it. And by using this dump, so within this, if you see, now this linear model is nothing but here you're having this intelligence linear model. Now this linear model, I wanted to dump it and I'm opening a file with the name linear model underscore pickle.wb. WB is nothing but read bytes. This process, we call it as a serialization, or we call it as a pickling, or converting Python file into binary file. Now, if you see, there should be a one file which got created called linear underscore model.pickle. So this is the file which I created. Now let me just show you this particular file in another thing. See this. Let me open this particular data. Yeah. So are you able to read this file? Are you able to read this file? Is it understandable? No, it is not understandable. So this is what we have done with respect to pickle library. So by using pickle library, we converted our linear regression into this particular pickle file. Now what need to be done from the client side is nothing, but we try to take this particular pickle file, which is having some memory space. If you see, The memory space of this pickle file is 7 KB. We try to take this and we try to send a mail to the client side stating that, hey, this is the intelligence file, what you've got. Now, after taking this particular thing, what we do here, after taking this out, now from the client side, again, they'll be doing from pickle, they import something called as load. They load this particular model, open the same pickle file, and RB is nothing but read bytes. So now this intelligence, they loaded this particular pickle file and they just given it in this particular thing. Loaded, I'm just giving it into loaded linear file. Now load a linear file dot predict. Predict is nothing but I'm passing some questions. Now by passing some questions, it is going to give us the answer like 0, 1, 2, 3. So this is nothing but what it is happening now in case if you're visiting to some websites like this, let's say used car, that is carwally.com, car evaluation, I'm doing it. Now I'm just selecting this. This is completely linear regression. So let's say it is an April make. Make is nothing but let's say Skoda. Select model, let us super. And select version, let's say it is elegance. Now city is nothing but let's say Bangalore. Number of owners is nothing but third owner. Kilometers driven, let's say 50,000. Can't expect. Big 1 lakh kilometers. Check value. See this? Fair condition car price, good condition car price. Now, by clicking on this button, machine has already learned this pattern. In case if I change anything, accordingly the output will get changed. So I'm getting the inputs, clicking on this particular check value button. So this user interface will be created by software developers, or let it be UI UX developers or any developers, they will be creating it. All the forms and everything, they'll be creating a logo, fixing it, everything. That's their job. Now, what is our job is nothing but behind this particular button, we have to attach the pickle file. By clicking on this, it is going to read the patterns. Let's say now I'm just going to change it. Let's say 50,000. Now, based on this, it is going to again change this particular pattern. So this is what machine learning. Machine learns the pattern to make a prediction. And here it is numbers. So we call it as a regression. That's how machine is learning. Got my point, everyone? So how do you feel machine learning? Is it easy or is it something hard? Interesting. I think Salodi feels hard. I think so. Okay. Jyoti will practice. It will be easy. Yes. Jagdish, interesting. The changer, great. Dr. Veera. Okay. Fine. So initially, if you get to see some things for the very first time, so it looks hard, but if you keep on doing it, regular practice and spending more time with scripting, trying to understand business cases, that's what the point. So if you see some YouTube videos or whatever it is, people used to post as a first job I got into Amazon, Google and everything, how they are getting it. They do a lot of brainstorming exercises. They try to pick up one business problem. They try to firstly understand the business point of view. As a fresher, you can't get selected as a data scientist. You have to work on multiple problems. You have to get some internship certifications. Only then you can just make this particular part. So for that, ExcelR can help you with that. But the point is nothing but if in case we fail to understand the business point, it is meaningless, it is pointless. So that's why even I've given some time for you to read the business problem, try to understand it. Okay. So then is it compulsory to bring confusion matrix as well before using regression? So confusion matrix is one of the evaluation metrics for classification problem statement. A lot of things, confusion matrix, we have mean absolute error, mean squared error, a lot of evaluation metrics we have. But if you look onto this notebook, I just parked that particular topic. We are not going to get into that for now. So model evaluation, this particular topic, I just parked it. This is where this mean absolute error, mean percentage error, a lot of things. How exactly now we build this model. Now, how can we say this model is the best model? Is it making a best prediction or not? How can we say that? So for that, we have to evaluate it. Correction we have to do. We have not corrected it. We have not, we can say we have not evaluated it. That's it. Maybe what we have done is nothing but you all are going for semester examinations. You have given the answers. Then that's it. How you come to know whether your answers is right or wrong, or what is your score? We have not done that particular part. So model evaluation part, I just parked it. Maybe you can just read about it, or if it is a program, I will be getting into in details of it because it demands 3 days time to understand this linear regression and multiple linear regression, to understand the whole topic of machine learning. So since this program is not focusing on that part, we are not going to get into that. But one day machine learning program, just giving you an idea how prediction is happening, how pattern is how machine is learning the patterns. That's what the major goal of this session. I think you all should be getting it. So is that part clear, everyone? How machine learns the pattern, how it is making a prediction? Is that point clear? Fine. All right. So that's it for today. So we understood how exactly machine learning is working. So it's all making a statement about future, making a statement about what will have early prediction. Based on some input feature, I have to make a prediction. That's what this machine learning is all about. So within that, we discussed about two divisions: supervised learning and supervised way of learning. So the problem statement, what we discussed today, it's a supervised learning because we are having a specific output y. That is Sunday circulations we had it, and we are also interested in making a prediction for Sunday circulations itself. So two divisions, regression and classification. When output feature y, if it is continuous, we call it a regression. When that specific output, if it is discrete, we call it as classification. Based on whether it is a parametric model or a non-parametric model, my algorithm will get classified. Parametric models comes up with a lot of assumptions. One is linear regression and the other one is logistic regression. So today we picked up linear regression and we tried to work on it. That is simple linear regression we picked up. So the parametric model's major deliverables is nothing but slopes and intercept. Without slopes and intercept, you can't go for the prediction. So now we picked that particular part and we studied it. And then we got into simple linear regression understanding. What is the major deliverables and everything we learned it. Experiences versus salary, we plotted it and we understood it very well. And then we discussed about what is the training time deliverable and the test time deliverables. And then we realized if the prediction need to be better, we need to have best slopes and intercept. If my slopes and intercept need to be the best one, my data need to follow some sort of assumptions. What are all the assumptions? The data need to be linear in nature. Input feature should be normally distributed. There should be homoscedasticity, no auto regression, zero residual mean, and no multicollinearity. So these are all the assumptions that we have to check it out. Now we picked up this newspaper case study and we understood why we have to undertake this particular project. Because before going with the daily circulations or Sunday circulations, what is the profit factor? I need to look into it. So if that is something matching my expectation, I will go for it, or I will never invest on Sunday circulations. It is at the end of the day, it is going to either save my money or going to generate more money. So it's all about business all about generating more money. So what is my priority? Accordingly, the business will try to go. So we understood the business case, where we are going to help it. We understood, we collected the data, we understood the data, we checked all the assumptions, and then we prepared our data, and then we go for model building where we separated input and output, and then we trained it by using dot fit method, and then we tested it by passing manual prediction also we done. But basically we don't go for manual prediction. We try to use dot predict and we see how exactly the results are, and then we evaluated it. But now in this session we did not go for evaluation. I just parked it, and then after, if the evaluation, if it is successful, if we have come up with the best model, we go for deployment. But for deployment, we need to collaborate with multiple teams, because if it is a web application, I can't go and build a beautiful web application. That's the job of web developers or software developers. They will be building a front end, and I will hand over the SPICL file to them. They'll be attaching it behind the button, go for the prediction. And we continuously evaluate it if it is doing a better job or not. So now The life cycle of a data scientist has been completely covered. Perfect. Perfect, Dr. Veera. Wonderful. Thank you so much. So Chaitanya, is it possible to apply AI in mechanical engineering design? Yes, automatic design, we can do that, Chaitanya. Already in mechanical engineering, a lot of AI things has been applied. Try to read about, if you're from a mechanical or electrical domain, how AI can be applied for mechanical engineering, mechanical engineers. So just try to Google it. A lot of blogs resource you can find it. Try to have a good understanding. Read as many as possible. So don't try to stick only with my lecture. You can just be open-minded and try to read many blogs. You have to read a lot. This profile demands a lot of brainstorming exercises. Reading, continuous exercise need to happen. I can help you some in particular way, but a lot of things you have to initiate it. You have to do it. That's it. If you're enrolling to the program, I'll keep on giving daily tasks. Daily tasks. If you're working on the daily tasks, even post 3 months also, I try to guide some non-programmers because most of the learners are from civil background, mechanical background, or even I try to guide them in case if they impress me with their works, the daily given task, if they submit it, if they are coming up, if they're showing it in the next day, I try to look into their efforts and the result also. They, because everybody can give their efforts, but I look into the results. What is the results? You work for 3 to 4 hours a day, but where is the solution? I look into the solution because everybody is working, but where is your solution? Even the company will look into that perspective. So no matter if you're studying all night, but are you getting passed or not in your examination? Only your parents are going to look into it. Only the result I'm focusing on it. So we need to be a result oriented person, not effort oriented person. So you can give your effort with respect to the IQ level, whatever you have. And if one person can get the concept in 1 hour, but if you take me, I have to write it everything. It will take, for me, it will take 10 hours to understand 1 hour topic which my friend has understood. So it completely depends on our IQ level, the way how we take it, our brain takes it. So accordingly, you have to go further. All right. So don't try to compare with one person with the other person. He's understanding, she's understanding. Why I'm not understanding? If you're going having that mindset, that will never help you out. You know better than anyone, right? So about yourself, you know better. So if you know about yourself better, the only thing is time factor. So invest more time on yourself, learning these topics. Definitely, it will pay you. And that's what even happened to most of my learners, even if it is 11 years career gap, 3 years career gap. Most of the people are from, two of my learners are from teaching domain and they wanted to get into this IT field. And even one of my learners, she's working on it. She's on it. She's already been more than 6 months, but she's keep on studying it. She used to be in touch with me. And I know her efforts, the project, what she completed. So the point is nothing but continuous effort. So it depends. Maybe within 6 months you will get placed, or 8 months or 9 months. It depends on your continuous effort, the way how you search. Okay. All right. So hope we have all had a great session today, machine learning. So tomorrow we are going to get into artificial or deep learning part. Okay. So we are having, I think, 9 more days we are having it. So we will be spending with respect to artificial intelligence. Fine. Take care, everyone. See you all. Good night. The same time, 7 o'clock. Bye bye.